area is still given. So my area is given as, and just set it up x and y, whether you set it up this way or you set it up this way, it's fine. So if you set it up this way, your area is x times y. Now, my perimeter, according to this, is 2y plus x, according to my chart. If it was this one, it's going to be 2x plus y. Same thing, your x and y will be reversed. This is what's going in my y1. Now I can't, when I go to my y1, I can't put this y in. This y comes from this diagram. So I have to go back to here, and I have to solve this in terms of y, in terms of x for y equals. So I divide both sides by x. What happens is your window is very large. So your window is going to be a little bit big here. This is what's going in place of this. So just substitute. So my perimeter is 2 times 180,000 divided by 2 plus x. That's going in my, divided by x. I'm saying two of those. When you put this in, your window is going to be quite large. Look at the size of this for this area. Even if I took the square root of this, figure if it was a square. Figure if 180,000 was a square. What is the square root of 180,000? Someone do it on their calc for me. This would be a good place to start.
Oh, it's 424.2.
So let's make it 500. Let's just round. Let's round. So we're going to be x plus, I have to go by this one. Okay, so now, we set our x value, even, remember your minimums have to be at zeros, because you can't have negative length, negative width. So my x value, maybe it's going to be, take the square root of it and figure like 500. I'm halfway. Square root of this, figure like 500. And double your, I don't know, this is probably, if I figure 500 halfway, maybe make it 1,000. Double it. Figure halfway and double it. Your y max, if you're doing perimeter, is it going to be more than your area or less than your area? A lot less, right? So even if I figured my sides were 1,000, maybe my max is 4,000. I'm just saying. Obviously, it's a little different than this, but will this give me a graph? Yeah, this will give me a graph. Now, remember the other day I told you, if this kind of flattens out on you, this is supposed to come up. How did I say to make this a little sharper? The x. Extend your x. Extend your x. Make this a little sharper if you can't find a minimum. See it go up a little bit? It's a little sharper. Now, why would I guess that? You could go to your table. Here's another way. Go to your table. Maybe. Maybe we can go to our table. Maybe not. Okay, we're at our table. Look at how large these numbers are. My minimum says it's going to decrease, 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 increase, increase, increase. I'm going to go a very long way with this decreasing, decreasing, right? I'm going to be here for a very long time. Maybe I want to jump this up. Maybe I want to say, oh, let's take a look at what the 200 looks like. This is another way to do it. Is the 200 still decreasing, decreasing? Is my y still decreasing, decreasing? I'm still going down, right? So, oh, maybe I want to go to 400. Get used to playing with your calculator. That's what we're working on. No, don't do a zoom fit. Because it's not going to adjust your window. I want you to work the window. Am I still decreasing? Still decreasing. So maybe I want to go to 600. Your best bet is to take the square root and figure it like a square. Wasn't everything else pretty much working like a square? Did you see that pattern? We were pretty much looking at a square. Does it mean they'll all work like squares? No, but it's a good place to start with your window. It gives you an estimate with your window. So now, at the 600, whoa, look where we are. We're pretty cool here. It's still, but this guy right here, it just increased. So if halfway through, if my turning point is at X is 600, what do I need to see the rest of it? That's my turning point, right? Isn't it halfway through? Double it. So make it 1200, make it 1500. Now, and then my minimum is here. That's the lowest Y. But my upper Y could be anything. So I go to my window and I say, okay, I'll take 1200, I'll double it, I'll make it 1500. And this guy I can probably leave, I'm not going to leave it 8,000. I'll leave it like this and see if I see something. And you do.
Why did you put 1500?
Because when we went to that table, I was at the table and I noticed it starting to increase because I jumped to 600. I noticed it start to increase. I said, okay, 600 is my halfway mark. Isn't that my turning point? So I doubled it to 1200 and I rounded it because I want to see a little bit more. God bless you. You're not finding that exact value for your window. You're just getting a window to look at it. So don't try to be exact on your window because that's what gets everybody. They try to say, well, let me find the exact point that it's turning. You don't have to. And if I estimated, even if I said 1200, this is fine with 1200. I can see more than enough with 1200. I can see my thing turn. Do you see it gradually go up? It's hard to find the minimum on a gradual because either you're going to set your X values to this high or you're going to run that little cursor thing all the way out here. To make this be sharper, just increase your X value. You can increase this to like 3,000. Watch what it does. It makes this a lot sharper. So isn't the minimum easier to find? Extend that X value. Your Y value in this case didn't make that much of a difference. Why? Why don't I really care about the Y value as much as the X? Danny, why don't I care about the Y? Which way is it turning? Down. So do I need the highest Y possible? I don't need the highest Y possible. I just need to see some kind of window here. This is my 0 right here. This is my 0. My Y min is 0. So my Y max isn't going to make that big of a difference. My Y max is just going to show me a little bit, but I'm still going to be able to see where it turns. Obviously, if I go too low, I'm going to miss it, but still I'm low enough, right? You've got to play with your window. Your window is just what you need to look at. Don't get too exact on your window. Take a total estimate. And I said these would be harder because the numbers are higher. These would be harder. But once you find your turning point, do your minimum. This X represents this X. This Y represents what? What is this Y? My perimeter. This guy right here is my perimeter. It's what I put in my Y1. But to find my other Y, come back to this equation that we did over here. Right to this guy. Substitute your X in and find your Y. Now, if you set this up the other way, if you set it up to look like this, you're going to come out with the same values, 600 and 300. They'll just be reversed.
I set it up like that way, but for some reason I got 300 and
300 and 150?
yeah, I got like my X because I got the 1200, but like my X is 300 for some reason.
Okay, let me see, because I set it up down here too. You got to get the same amount. Oh, when you went back here, was your X 2X?
Yeah.
It still was 2X?
Right then. Wait, I plugged in 2X plus button. Yeah, I plugged that.
Yeah, now when you come back to the X, don't forget to plug the X in here and here. And you'll get the 600. It's got to be more, doesn't it? It's got to be more than your X. It can't be
I
less.
plugged it into
To the other part, yeah. You got to come back, plug it in. For whatever one you did it for. I don't know which one I set it up for.
Just one X because of the
For this guy, I had 2 X's. Well, that was the other one. If you set it up, you could set it up the opposite way. Where'd my thing go? This guy has 1 X. If you set it up where these are your X's and this is your Y, then you have 2 X's, 1 Y. But you're still going to get the same values. In other words, when you drew your rectangle, you said, you labeled this X, right? You labeled this Y. Well, what if I said, label this X, this is X, and this is Y? Is that wrong? As long as these are both X's and these are both, and this one's a Y, I'm okay. It's just it comes out the opposite way. Watch that window. The window is the toughest part. Okay, now this one, I realize my writing is off again, but I need the space, so I'll pick up this instead. This one, I gave you this one, right?
Yeah, I gave up on this one.
Why? I gave you the diagram. Didn't I give you the diagram?
Yeah.
Okay. Okay, your rancher has 200 feet. It's up there. I just can't bring it down at the same time. Has 200 feet of fencing in which to enclose 2 adjacent corrals. And your corrals show the fencing. His fencing goes all the way around the outside, right? And his fencing goes here as well. He needs an extra piece. What dimension should be used so that the enclosed area will be a maximum? Well, what does that say? Enclosed area will be a maximum. There's your part. Area, maximum. This is the part that you're going to put into Y1. You're going to use the fact that he has 200 feet of perimeter, of fencing for his perimeter. But this is the part that's going into your Y1. I want to maximize my area. Now, your area is going to be a little bit different. Start labeling this. If you didn't label this, try to label it the way I did. There's 2 separate pieces. So all of these guys, I called X. Could you call that Y and call the other one X? Absolutely. But if you didn't do it, label it so that it just matches this. Then I labeled these guys Y. Now, my perimeter has to include all the fence. So this X plus this X plus this X plus this X. So that's 4X plus Y plus Y plus Y. That's my 3Y. That's my perimeter formula. My area formula says length times width, right? Is my area still length times width, base times height? So length times width. What is the length of this rectangle? 2X. What is the width of this rectangle? Y. Figure that it's a straight rectangle. This is my area. This is going in my Y1. I'm maximizing my area. Whatever I maximize or minimize goes in my Y1. Yes. How I got the area. Did you lay it out like this? So this is just, let's call this a rectangle. Even though it's slanted, it still says a rectangle, right? 2 adjacent rectangles, even though this is slanted. It's just, they are rectangles. What's the area of a rectangle? Formula. What's the formula? Length times height, okay? What's the length of this rectangle? 1x plus 1x, right? What's the height of this rectangle? That's where it came from. It looks strange, and I apologize. The diagram is slanted, but it still says 2 rectangles. Okay. So now, this is going into my Y1. This is my Y1. This is my information given. This is my perimeter. So I figured this out. Now, I need to get here and substitute out this y because I can't enter that in my y1. It's a different y. So I come back to this formula and I solve for y in terms of x. I subtract my 4x, I divide by 3. This is the y that substitutes into that y. Okay, now 200 feet of fencing. Even if you figured it this way, I have 1, 2, 3, 4, 5, 6, 7 sections, right? 1, 2, 3, 4, 7 sections altogether. 200 feet. So maybe they're 30 each, right? Estimate it. Maybe my x is 30. Here's a good way to put this in. If this is 200, you see where I'm getting the 30 from? Each one of these is 30, each section. So what would x be? 30, 30, 30, 30. 120. So maybe my x max could be 120. Is that a good way to start? Absolutely a good way to start. If this is a maximum, what is your graph going to look like on a maximum? Turn up or down? Turn down. So I want to see my y increase, 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 get to the top, decrease, decrease. Now, play with your window. The perimeter is a little easier to play with because it's not as big. The numbers are not as large. So if I just take a look at, 7 section of these, maybe they're 30 each. So set your y value, set your x value first. Go to your table, look around there. They're not that large. If each one of these is 30, go to 30, see if you see a turn. It's not going to take that long before it turns. Reset your table. Don't forget to start back at the 0. Reset it and start by 1. Could I always reset my table like in the other one? Could I reset my table and start by 100 and go by 100? Is that, maybe my calculator is still up. Oh, maybe not. Okay, yes. So you know how this table was so large, the last one? The table was so large. Could you do this? Reset your table. This is another way to do it. This is the last one. Say my x max, I don't know what my x max is yet. So say I did this, but say I went to my table set and I said, start at the 0. I have no idea where this is going. And increment me by 100. Look what my table tells me, if I can get there. Look what my table tells me. This guy was the minimum, right? It was decreasing, decreasing, then increasing. These are decreasing, 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 decreasing. Do I see it a little bit better? Upside just increased. So could I do 600? Could I set my table to 100 and then just estimate between there? That's another good way to do it. There's not one way to do this. Get a feel for it. I really like to get a feel for the numbers. Set your table when the numbers are large. This one's not so bad because it's a perimeter. So when you put that in, maybe set it by 10s. Set it by 20s. Just until you find your window. Estimate your window. Don't struggle finding the exact turning point. That you'll do with your minimum and your maximum. Don't sweat that on your window. This is another great way to do it when the numbers are large. Oh no, this is for the last problem. I know that this is different, but remember I just said like the last problem the numbers were really high. Another way to do it is just change your table set. Start at 0 and increment by a large number. Not this one, because this one has the smallest perimeter. But when you're doing area is a lot larger when you're given the area. But that was another way to just go through your table. This one, put it in your Y1, just take a look at your table. If you find yourself scrolling, set your table set up. Go by 20s. Go by 50s. Just get an estimate for where it's going to turn. You do not need to be exact on your window. Your window is just what you look at. Can you always change it if you don't see a turn? Absolutely. Or guesstimate. This is 200. I've got 7 sections. Each section is 30. So my x, maximum 30. And I want to take a look at where my table is. What does my y look like? That's the one that's been concerning. My y. So take a look at your table for this guy. Does it make a little bit more sense? Kind of yes, kind of no. And for your calculator as well. It says on a given day, the flow rate X, these are cars per hour on a congested roadway, is given as this formula, where V is the speed, it's like velocity, of traffic in miles per hour. What speed will maximize the flow of the rate of traffic on the road? So maximize, what does that mean? Since it tells me maximize, where do I put this? So where am I going to put this? In your Y1. You're only given one thing with one variable. You don't have to find anything else. So let's go put this in your calculator. This is a great calculator one to work on. So get this in your calculator just like you read it. If you do this without a fraction bar thing, make sure you put parentheses around your denominator. Instead of using V, yes, you can use X. Always use X. Okay. Now, we're looking for, what should our X value be representing, or your V here? Your V is what? Speed. What does speed of cars usually go to? Yeah, like between what?
16.
Well, you're on a congested road.
Don't worry.
So 20, let's say 20 to 50. That's, what value is that going to be? That 20 to 50, what is that going to be? My X, right? So, okay. So now I need to find my Y to get a window here. So I know my X value is going to be about, oh, I'm still by tens, which is okay. It's going to be between 20 and 50. So look at my graph. Wow. Look at my Y values. What kind of values are those? Decimals, very, very small. So that gives me a good hint. What should I make my window? Ah, I'm maximizing. So aren't I getting bigger, bigger turning? So somewhere, did I turn in here somewhere? So where's my maximum X at? Between where? Somewhere between 20 and 30 and 40. So that's halfway where I'm turning, right? I'm maximizing. So let's think about this for a second. Let's go to your window. What should I make my X max be? 60. That sounds good to me. I took 30, I doubled it. I should scale by once. My Y max. What should I make my Y max? 1. I can try 1. Okay, let me see what my graph looks like. Oh, do I see it turn? Yeah. Kind of a little flat. Can I make it a little sharper to get the maximum? What should I change? The X. What should I do to my X? Make it a little bit bigger. Well, I'm going to make it 200 because I really need to just get this turning without going crazy. Right? So can I find my maximum now? Make sense out of your problem. I knew if I gave you this, with the Y being so small, if you didn't look out your window, you weren't going to get it. So, guesstimate what your X is. Take a look at that table. That so gives it away what your Y's are going to be. So can you find your maximum now? So when you find your maximum, so let's just graph this. I know I have a maximum. I'm looking for this. This is going to be, what'd you find for your maximum? 33.167. And what is your? 3.4. Okay. Now, this represents my X value, which is my speed. What do they want to know? They want to know what speed will maximize this. So there's my answer. 33.166 miles per hour. That'll maximize my flow of traffic. In other words, when they're looking at this, this is a congested road. If people don't go the same speed, doesn't it get worse? Even though you guys don't drive, haven't you been behind cars that say, what is holding us up? That's because these guys are going so slow and those guys were going a lot faster. If you have one steady flow of traffic, your traffic should flow a little bit better. So that's where that came in. So does that make sense? Okay. What's window going to be? Because you're changing windows all the time. Kind of like if you got a little bit used to that now that you're changing your window, you're always changing windows in here.
I had it right last night that 0 was there instead of 4.
How high is the ball when it leaves the child's hand? Well, where is it at the 0?
4.
At the 4 feet high. If you're throwing a ball, do you throw it from the ground? A lot of times we graph it from the ground, like we're golfing it, but technically you throw it, and if I'm throwing it, where's my hand? Up here, higher than me. So a 3-foot child is probably going to throw the ball, raise her hand and throw it, right? Or his hand and throw it. So they're off the ground. This is where your X is at 0. And graph this guy. This was a nice little parabola. Go back to a zoom 6 for this guy. And then change what? What quadrant do you still have to be in? Quadrant first, the 1. So change your X min to 0, your Y min to 0, and you're certainly not going to be very far on this, right? So it asks, when does it leave the hand? How high will the ball be at the maximum? Can you just do a max on this? And how far from the child does the ball strike the ground? Now, this is what was different about this. This is where the difference came in. X is not the time. X is the horizontal distance. Normally it's time and height. So I threw this in at you because X is the horizontal distance. So when you find out when it hits the ground, you didn't find the time, you found out the distance. So how do I know when this hits the ground? When my Y is 0. So do a second count zeros and find out when it hits the ground. Okay. 3. Okay, do number 2 and 4. 2 and 4. And God, go over whatever you didn't get today. See if it makes more sense.